My name is Shubham Gupta, and I am the CEO and founder of Space Resources Laboratory. And today I'm going to walk you through a journey to making space accessible to everybody and how I got into the space industry, how I realized that CubeSats can be something that can be made, can be utilized to make space more and more accessible to the smaller industries, to individuals, et cetera, et cetera. So that's myself. I did my bachelor's in mechanical engineering from SM University, India, and my master's in astronautics and space engineering from Cranfield University, UK. And I'm currently based in the UK again. But I'm going to dive back to 2014. So I was doing my bachelor's in SM University when I heard about this team called SRM-SAT, and I heard they're recruiting for a mission to the moon. And I said, okay, why not? Let's apply for this. So this essentially was a university mission to send a microsatellite to the low lunar orbit using articulated low energy transfer, or by exploiting the invariant manifolds and the Lagrange points in the Sun-Earth system. So that was very interesting. So I went there and I joined the team in 2014, initially as one of the team members of the structures department, but I went on to lead the structures team. For those of you who are not aware of what SRM-SAT is, SRM-SAT was it is India's first student satellite that was launched into space in 2011 and is still orbiting the Earth, which is quite impressive. And SRM-SAT-2 is the successor to that, and it was to design a satellite to send to the low lunar orbit. I worked on the structures team and I got 4 research papers out of that. And this was really my moment when I realized this is what I love and I want to continue working in the space industry. And because I was working on a microsatellite mission, I realized I came across CubeSats and I realized, okay, it's quite interesting. These are something, these are such small satellites and they're now able to do what was once only possible using large satellites. So I was like, yeah, why not? Let's research a little bit more into this. And then I said, okay, I want to pursue my career in this. I want to do my master's in the same field. So I came to Cranfield University and I did my master's in astronautics and space engineering. But it wasn't. It was very nice when I started, but what happened was I was really lazy during my studies, and I missed out all the deadlines for the graduate roles, and I missed out all the space companies, and I couldn't apply for them. Some of the roles that I did apply for, I couldn't get through to the graduate roles. So I had nothing to do. What I did was I started scouting space companies in the UK. I found a website which had a list of all of the space companies, including startups. And I came across this company called the Asteroid Mining Corporation, or AMC. They didn't have anything on their website. All they had was an inquiry page. So I said, okay, I have no job. I have nothing to lose. Let's talk to AMC. I sent an inquiry to the inquiry form saying, this is my background. This is what I work on. Is there something, is there a role you need? Are you recruiting? And the CEO got back to me saying, we're looking for interns at the minute. Would you like to do an internship and present that as a part of your thesis? I said, yeah, why not? And I worked on a CubeSat. I worked on a 6U CubeSat using honeycomb structures. So that was quite unusual for CubeSats to use honeycomb structures. And I worked in a lot of unpaid roles only because I wanted to continue with the space industry. But at the end of my internship, I actually had to end up going back to India because visa sponsorship used to be a massive issue in the UK. Well, now you have a graduate visa, but back then, once your student period ends, if a company cannot sponsor your visa, you have to go back to your country. So that's where my journey began. I went back to India and I started applying for jobs. And all I knew was I wanted to get back to the UK because the startup culture in India wasn't as good as it is now. You see lots of startups blooming out of India now, but back in 2018, the situation was quite difficult. 2018 and 19, you would only see software startups. None of the engineering startups would think of incubating in India. So I started looking for a visa, and it took me about 6 to 8 months to get one. I came back to the UK after registering this company in the UK, and then COVID starts. But that's when the company really started. I started rebuilding my team. I started finding people who were actually believing in the idea of making space more and more accessible to everybody. And that's when I contacted my good friends, Vyom and Neil. They're also from Cranfield University. Vyom is my batchmate from Cranfield. He did his master's in automotive engineering. And I said, okay, look, this is something that we're doing at the company. Would you like to be a part of it? And he said, yes. That's when we started finding investors, and at the very end of last quarter of 2021, Space Resources Laboratory received its pre-seed round of investment. This is our brilliant team. Me, Vyom, and Neil are just in the background. We're just in the foreground, but it's the other members of the team who actually make it happen in the background. You can see the team working in the background in this image. But let's talk about Space Resources Laboratory now. Space Resources Laboratory is essentially a space subsystem provider, and we're working to make accessibility to space more cost-effective, intelligent, and space environment friendly. Our vision is that space is for all, because space is very important. Space, consciously or subconsciously, we're all using technologies enabled by the space industry in our everyday lives. It can be satellite navigation, telecommunications, television, anything. So yeah, I talked about CubeSats, and this is what we're doing at Space Resources Laboratory as well. We're building CubeSats to make space more accessible. For those of you who are familiar with the space industry but not CubeSats, I will just quickly explain what a CubeSat is. So CubeSats, if I can use an analogy, they're the elves to the shoemakers of space. They're miniaturized satellites of the form factors of a 10 centimeter cube, and they're now able to do what was once only possible using massive satellites, and only possible by space agencies, really. But these are so small that they're very cost effective, they're very easy and very fast to build, which gives you the capability to test your experiments in microgravity in space. And one way to be successful is if you can fail fast. CubeSats allow you to fail fast. They're primarily used for LEO, but the low Earth orbit, but they're quite capable of interplanetary missions as well. There was a mission called Mars Cube 1 launched by NASA, and it was a pair of 2 6U CubeSats that was launched to the Martian orbit. But yeah, CubeSats are really, really versatile. They can help you with satellite navigation. They can help you with Earth observation, telecommunications. There are companies who are testing microgravity using CubeSats. They're building small labs inside CubeSats, in which you can perform your biological experiments. There are asteroid mining firms which are utilizing CubeSats for near-Earth object surveying, for hazard perception as well, to some extent. And yes, the possibilities are endless. Looking at the satellite market, so CubeSats, or the small satellites, they cover a massive fraction of the entire satellite market. The terms might be a little odd because this is how Bryce terms its satellites. This is how they categorize the satellites. So yeah, so we are looking for a massive market. We're only looking to capture a very small fraction of this massive CubeSat market. When the demand is increasing more than ever, we've seen in the past few years that the demand increased drastically, and projections and surveys show that the demand for CubeSats is only increasing exponentially, and this might be the right time to enter the CubeSat market. Our products include CubeSat structures, propulsion systems, deployers, battery modules, magnet talkers, launch services via our launch partners. Uh, Two of the things that you can readily buy right now are CubeSat structures and magnet talker coils. Our CubeSat structures and both our CubeSat structures and magnet talker coils are available with lead times of less than a month. So if you're looking for one, please contact us and we can help you with that. But one of the things that I want to talk about and a product that we're building to solve is a problem that we're tackling is space debris. Space debris is a growing concern for the space fraternity. There's an estimation that more than 128 million pieces of space debris exists in the orbit, and they can range from old satellites to rocket stages to even paint flecks, which might not seem like a big concern. But when an object is orbiting at over 25,000 kilometers per hour, it's like a bullet. The momentum is so high that it can tear through massive satellites. So it is quite concerning. And another problem with space debris is that tracking and monitoring 128 million pieces is very difficult. It's very difficult to find these, to find the debris. It is very difficult to catalog and make a database of the debris. And real-time tracking of the debris and the trajectory is very, very difficult, which can lead to potential collisions, which means we need to have regulations in place. Currently, the regulations say that if you have a satellite in low Earth orbit, it must deorbit within 25 years, but we need regulations to be more strict. The FCC recently adopted a new 5-year deorbiting policy, which I'm not sure if it is in place or not, but very soon we're going to see regulations more strict. They will require satellites to deorbit satellites to be deorbited at the end of life within a certain period of time. This is where we come in. So we're working on this project called Project Aryabhat, which is named after the astronomer and the inventor of the symbol 0. So we're developing a propulsion system that will deorbit your satellite from low Earth orbit at the end of life in less than 5 years. So what we do is at the end of life, it will intelligently compute the thrust required, the thrust vector required, and fire its thrusters, and the CubeSat will start sort of spiraling into the Earth's atmosphere and eventually burn out. It's not just to reduce space debris. By doing so, we're also enabling potential for more frequent launches of satellites. We can potentially increase the frequency of launching satellites by 20 times. This is going to help our environment. This is going to help economically. This is going to help more and more experiments go into space and just further the developments in the space industry. This is the project still under development, but if you're interested to know what we do, please get in touch, and somebody from the team will be more than happy to talk you through what we do. This is just a little recap of our journey. We've the best thing we've done is we've built the best team. The team is what has made Space Resources Laboratory what it is today. We've raised a pre-seed round, and we've raised and we've also won the Aerospace Up grant from the ERDF, which is the European Regional Development Fund, I think. We're incubated at Cranfield University and the University of Warwick. We're also named the Aerospace Company of the Year last year, and I was recently named on the Forbes 30 Under 30 Europe list. And let's hope we can help space debris using our propulsion system. But if you have any questions, I'll be more than happy to answer your questions. Thank you very much.
Awesome. All I can say is definitely awesome, Suham. I mean, it's since the last time you have been talking, and for the people who don't know, you have been presenting on the International Space Convention 22 last year in Bursa, Turkey. So it has been a lot of improvements and I mean improvement, just a lot of growth. That's what I'm trying to say. So I
Mhm.
congratulate you on that one. I mean, definitely, this success doesn't happen overnight, and it's definitely a team effort, which you emphasize, through the presentation. So a couple of questions. So one question. So let's see, we have here in a chat. So are you aiming to deorbit CubeSat sized satellites only, or larger satellites as well? And that's coming from Mikhail.
Thank you for your question, Mikhail. So at the minute, we're only designing this propulsion system for CubeSats, but there's no reason we cannot scale it. Once we have developed the propulsion system and we've tested in space, I think we'd be able to scale it for bigger satellites as well. It's just that we need to get it in space and working, because space actively deorbiting satellites will be a challenge for us as well. So once we've demonstrated the technology in space, yes, we will definitely be looking to scale it for bigger satellites.
Got it. And there is another question coming through here,
Sure.
which, so give me a second. So the question is from Gavin. So he says, how far has the development of Aryabhat propulsion system, and is it in the early design stage or manufacturing? Also, what is the size of your team? So maybe Gavin is looking to explore working with you as well.
Well, thank you so much, Kevin, for your question. So I'll start in the reverse order. Our team is quite small. We're about 7 people now. We're getting a few more. We're getting 2 interns who will be looking after marketing and business development, and we're getting two more interns who will be looking after a thrust measurement device and the battery modules that we're building. And in terms of the progress for Project Aryabhat, so we have our designs. We have our designs simulated on computers, on paper, and next month we'll be testing the physical system as well. So let's see how it turns out, but hopefully we'll be able to get some successful numbers, and we'll be able to share more information once we have some concrete data to share with you.
Perfect. And a question here from me, as we had some conversations with individuals, let's say they're working on DART missions, and anything that comes through deep space missions is a fascination for a lot of people, including myself. So the question for you, Shubham, would be around CubeSats, and how are they being used for interplanetary missions, and what technical challenges need to be overcome to ensure their reliability and longevity in terms of harsh environment that they experience while going through deep space?
Well, that's an excellent question, Martinez, actually. So the thing with CubeSats is obviously they're able to do a lot of the tasks which was once possible using massive satellites, but their reliability is still a concern, and that's why you don't want to be risking interplanetary missions with CubeSats. However, with the recent developments in electronics and the propulsion system, I think it is very soon that we'll be looking at more and more CubeSats for scouting missions, especially. So take space mining, for example. It's not going to happen overnight or over a period of 5 years or 6 years. It's going to be at least a decade before we see any sort of space mining actually happening. And to do that, one of the major concerns is to go to the right asteroid, because you don't want to say you went to that asteroid and it is not worth mining and it is not feasible. So you will be seeing a lot of precursor missions to space mining, and a lot of them will be performed using CubeSats. The other concern is within interplanetary missions is the fuel, the propulsion system. Now, CubeSats have a very limited size, and propulsion systems, they occupy anything between 35 and 45% of the entire satellite mass. So electric propulsion would be the way to go if you want to use CubeSats for interplanetary missions. But it's still in these things are still in development, and we'll see them fairly soon, I think.